Good morning to one and all. Myself, Varsha Jauhria, Assistant Professor of Modern Institute of Pharmaceutical Science, Indore. Today, we are starting our practical series of instrumental method of analysis and experiment number first, demonstration of gas chromatography techniques, GC. So, experiment number first, and the object is to demonstrate gas liquid chromatography or gas chromatography. Our requirement is gas chromatograph instrument, syringe needle, and sample mixture. Theory is gas chromatography is a term used to describe the group of analytical separation techniques used to analyze volatile substance in the gas phase. In gas chromatography, the components of a sample are dissolved in a solvent and vaporized in order to separate the analytes by distributing the sample between two phases. First is stationary phase and another one is mobile phase. Mobile phase is a chemically inert gas that serves to carry the molecules of the analyte through the heated column. And stationary phase is either solid adsorbent, termed gas solid chromatography, and if liquid on an inert support, termed gas liquid chromatography, which is GLC. So, um, this is the instrument of gas chromatography, which is used for performing analyzation of volatile substance mixture of separation of volatile substance mixture. So, how to work gas chromatographic system? These all are components which are attached to the chromatograph system. Process line, prop, sample return, sample stream, sample system, chromatographic ovens, sample valve, separating column, detectors, GC. Here the cylinder is attached to the gas chromatographic system, and mostly carrier gas in a high pressure cylinder with attendant pressure regulators and flow meters. Helium, nitrogen, hydrogen, argon are normally used for gas carrier carrier gas. Helium is mostly preferred for thermal conductivity detectors. And in this tank, in this tank, carrier gas from the tank passes through the tank wall. A flow meter, which flow rate is 1 to 1000 ml per minute, capillary restrictor, and a pressure gauge 1 to 4 atm. Here the sample injector system. Liquid sample is injected by microsyringe within a needle inserted through the self-scaling, which is made up of silicon rubber system, rubber septum, into a heated metal block of resistant heater. Gas sample are injected by gas tight syringe are through the loop and valves. Here the separation column is attached. This is the heart of gas chromatography. It is the column which is made up of metal bent in U shape or coil shape into a spiral or flat pancake shape, which is made up of copper is useful up to 250 degrees Celsius temperature. Sewage lock fitting make column insertion easy. Several size columns are used depending on the requirements. So, next, detectors are used in gas chromatographic system. Detectors is the main function of detector is to convert radiation signals into electric signals, and in gas chromatography detectors sense the arrivals of separated components and provide a signal to the recorder. These are either concentration dependent or mass dependent, and here the recorder is attached, which is display of gas chromatographic system. The recorder should be generally 10 MB full scale, fitted on a fast response pen, 1 second or less. The recorder should connect it with a series of good quality, resistant, connected across the input, attenuated a large signals. First procedure is first procedure sample injection of valve. Sample injection of valve, a small amount of liquid sample to be analyzed is drawn up to syringe. The syringe needle is positioned in the hot injection pot of gas chromatographic sample is injected quickly. The sample is dissolved with a carrier gas and liquid sample is converted into gas form and combined with carrier gas and column is heated up to 250 degrees Celsius, which converts liquid sample into gaseous and vapors form. And this signal will detected by detectors, and detectors give signals to the detector recorder, and recorder will display the graph of separation mixture. Uh, So here the video of gas chromatographic system, how to perform gas chromatography. Oven is attached, which is the separation column. The heart of the gas chromatography is the column, which is made up of metal in bend, U shape or coil shape, open spiral or flat pancake system. Here the injector is connected and detector, flow controller, carrier gas. Carrier gas from the tank passes through the top valve and flow rate is maintained by flow controller, which is 1 to 1000 ml per minute flow rate, and pressure is 1 to 4 atmospheric pressure. And the injector is connected with oven and detector. Injectors, a liquid sample is injected by a micro syringe with a needle inserted through the cell scaling silicon rubber septum into a heated metal block resistant heaters. The gases are injected by gas tight syringe or through by loop valves. Typical sample volume is 0.1 to 0.2 ml. And the separation column, the heart of gas chromatography column, is heated up to 250 degrees Celsius, and it converts liquid sample into gaseous form and vapors form and combined with carrier gas, and this signal is detected by detectors and detectors give signals to amplifier which amplifies the results and the graph is displayed on recorder. This is the injectors. A small amount of liquid sample to be analyzed drawn up to a syringe. The syringe is The syringe needle is positioned in the hot injection pot of the gas chromatograph and the sample is injected quickly. The injection of sample is considered to be a point in time that assume entire sample entered in the gas chromatography the same time. So that sample must be injected quickly. The temperature is set to be higher than boiling point of the component of mixture so that components will vaporize. The vaporized components then mix the inert gas mobile phase to be carried to the gas chromatographic column to be separated. This is the column, separation column. Components of a mixture are separated based on their ability to absorb or bind to stationary phase. A component that absorbs most strongly to the stationary phase in the column for the longest time will therefore have the longest retention time. It will emerge from the gas chromatograph last. A which component that absorbs least strongly with the stationary phase will spend least time in the column, will retain in the column for the shortest time, and will therefore have the shortest retention time RT. It will emerge from the gas chromatograph first. If we consider two components mixture in the component A and component B, component A more polar and component B less polar than component A. So now detectors, many types of detectors used in gas chromatographic system. First is flame ionized detectors, which used flame for the detection of sample. This is the graph of chromatographic system, and these all are separation compound. Thank you.